Welcome to a new video. Today we'll be looking at a type of device which I believe is gaining more and more popularity, especially as summertime approaches and people are spending more time outdoors. It's no secret that we are dependent on our gadgets now more than ever, so we need to keep them charged. If you remember video 417, I did a review of this power station. It was the blitzwolf PG1, and I've been occasionally using it when going on a trip. It's been serving me well, but if there's one thing that I don't like about this station, is that it's just too big for my needs. I never depleted this more than 50% of its capacity, yet I'm carrying around a lot due to its internal batteries and metal case. So today we'll be looking at another power station. It's the AllPowers S300. And before I continue with the review, let me mention that the unit was provided for free by AllPowers, and it was sent directly from their website for the purpose of this review. And should you decide to order one after watching the review, there will be a link provided in the description below, as well as a coupon code so you can get a discount. So do check them out. They have multiple warehouses, including in the EU, so that means fast delivery via local courier without any customs to deal with. So this S300 power station has 74 amp hours of capacity built into it. It's a bit smaller, which makes it a perfect fit for my needs. You get 3 USB Type A ports, plus a USB Type C to the power delivery capability, capable of up to 60 watts input and 100 watts output. We get a couple of DC jack outputs, 12 volts, 5 amps, not sure if each or together. It's got a basic built-in 5 watts wireless charger. We also get a cigarette lighter output in here, which can do 12 volts, 5 amps. I'm not sure if this is shared with the DC jack outputs on the other side. It probably is. You can charge via this DC jack input, which can take up to 20 volts, or via the solar panel input, or via the USB Type-C port. The solar panel input is done via this Anderson polarized connector, and I also got the optional portable 100 watt solar panel with the unit, so I can charge on the go. On the front of the unit we get 2 AC outlets, and these will be delivered according to your location. I got the EU socket here. They quote true sine wave 300 watts maximum capability for these, and I believe it is shared between the two. We also get the usual flashlight that we see on this power station. There's 2 LEDs on the front of the unit, and I can attest that these can definitely be very handy when going out camping. Unit was fairly well packed with plenty of protection foam, and it arrived completely discharged, which I'm not sure is a good thing. I mean, it is in terms of shipping safety, but it's not good for the batteries to stay that way for too long. This video is sponsored by PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. But you can get more than PCBs manufactured with PCBWay. They also do PCB assembly, injection molding, 3D printing, machining various parts, so you can have an entire prototype built using their services. Check out their website, linked below. Together with the power station, I also received its wall charging adapter packed inside this nice little carry case. The charger is rated for 20 volts 3 amps, so that's 60 watts, and it should take approximately 5 to 6 hours to fully charge this from the wall adapter. However, this station supports a nice little trick. It can combine 2 charging methods, so you can supply it with a primary charging source to choose from, let's say, solar or the wall socket, and you can go with those up to 80 watts. And a secondary source can be the USB Type-C input up to 60 watts, and thus supporting a total of 140 watts input for the shortest charging time. And I'm curious to test that functionality on the workbench, so stick around for that later in the video. I very much like how compact this unit is. I like how this carry handle is designed. It's a fair bit lighter than the blitzwolf unit, so I would very much prefer to carry this one around. I believe it is completely made out of plastic, but feels like good quality plastic. It feels like it could withstand some shocks. And now after also testing the heavier metal case on the blitzwolf power station, I can tell you that I would always choose the lighter plastic one, just because it's easier to carry around. There are some ventilation holes on the sides and on the back, and there is also a small cooling fan inside which turns on with the AC socket system. So there is a good chance of dust, sand, water ingress. So I would probably take care to run this as clean as possible. I would not just throw it on the sand, because you'll most likely get that inside the unit. On the front of the unit there is this nice status LCD, and let me peel off these protection stickers. There is a Bluetooth functionality and a smartphone app for iOS and Android to connect to this power station. To turn on the unit, you shortly press the DC button, which lights up green, and a confirmation sound is played. Now, having this status LCD is a nice feature because you can get a quick glance at the remaining battery capacity as well as runtime. It also shows which of the outputs are active, how much power you are taking out of the unit. So it's a pretty nice status display. Now, pressing the Bluetooth button for a few seconds activates the Bluetooth connection, and the icon is shown, the button lights up green, and now the device can be discovered by the app. I must say the app runs surprisingly smooth and actually looks good. It shows the remaining battery and a countdown timer, which is updated based on the load. It also shows the input and output power and offers you control over activation of the AC inverter or the DC system, as well as the LED lights, which is pretty convenient because you can have the power station in your tent and you could be 5 meters away at your campfire, for example, controlling this from your smartphone. When the DC voltage system is not in use, or even generally when there's no action for a timeout on the power station, the LCD will turn itself off, but the Bluetooth connection remains on, so you can monitor it via the app. The wireless charger is just a basic 5 watts model, and it does work, but depending on the phone model you have, you might be running into some issues like I'm having. Now my phone has this very important bulge because of the camera modules, and it just doesn't allow it to sit flat on the charger. Thus, I can't get it to charge. There's just too big of a gap between the phone coil and the charger coil. Now other flatter devices might be able to charge on this, so it is an oversight from the mechanical design. This should have been like a small raised island for the coil part. So everything sounds good on paper about this power station, but let's start testing it. First, I'd like to check the charging from multiple sources feature at the same time. I'm gonna use the USB Type-C PD charging port plus the solar panel input, which I'm supplying from my bench power supply unit with approximately 22 volts, which should be in the range of the solar panel output. Then I plugged in the USB Type-C from my other power bank, which can output power delivery up to 65 watts. And as we notice, the app and the status on the LCD report over 120 watts going into the power station. So that input charging sharing functionality really does work, and you're able to charge the battery much faster this way. Now I'm not sure why it's only taking 65 watts on the solar input. It's probably something to do with the MPPT circuit, which is limiting based on what it thinks my power supply can output. But nonetheless, this is going to offer you a shorter charging time. So thumbs up for that. Next up, I tested the USB Type-A outputs, and upon checking the user manual, I found that they advertise these to be 5 volts 3 amps per port and up to 7.2 amps maximum. So I've plugged 3 different electronic loads into the USB Type-A ports, and while increasing the load, I've noticed I wasn't able to get up to that claimed 5 volts 3 amps. The station would cut off at anything above 2.3 1 amps sooner or later. So I could get 5 volts 2.1 amps from each one of the 3 ports, so roughly 30 watts total, but not up to the spec of 3 amps. So the station would just cut off on, presumably on an overcurrent event. It beeps, it turns off the DC circuit, so at least the protection feature works nicely, but it just cuts off much earlier than expected. Next, I looked at the USB Type-C PD output, and it should be capable in theory of 20 volts, 5 amps, 100 watts. I'm using this tiny PCB, which is a power delivery trigger, to request the 20 volts level, and I've slowly increased my electronic load, but after 65 watts the station cuts me off. So again, an overcurrent condition. So this spec seems to be exaggerated as well. I'm only able to get 65 watts and not the claimed 100 watts. It is still sufficient for most needs. Next up, let's test the AC outputs on this power station, which should be capable of 300 watts pure sine wave. And my method for testing this is to run the Raiden power supply off the AC socket on the power station and then dump the power from the Raiden power supply into my electronic load. And I'm slowly going to increase that electronic load, the current setting, so that we increase the load on the power station. So right now the station is showing about 250 watts of load being present on the AC socket. Now we can't really take for granted the value that we see on the power supply or on the electronic load, because this power supply is not 100% efficient, so there will be some losses between the power station and the output of this power supply. So my goal here is to be able to see close to 300 watts displayed on the power station. Then it seems to be showing 300 watts, more than 300 watts right now on the power station. I'm gonna let it run at this level for a few minutes just to see if it goes into some kind of protection for overcurrent or over temperature. So it's been running fine. I don't think it's going to be tripping any of its protection features. It does seem to support the full 300 watts output power, but of course the AC inverter inside this power station is the most inefficient subsystem built into this, and so you wouldn't get much battery life if you were going to be running this at its full rated power over the AC sockets. So as shown here in this capture from the app, we don't get much runtime. It's about half battery charge right now, but we don't get much runtime at this full output load on the AC sockets. Like I said, it's the most inefficient part, and it is what it is. All power stations suffer from this inefficiency on the AC inverter. Doing a quick thermal check with a thermal camera after running the AC inverter on full blast shows the highest temperatures to be around 50 to 60 degrees Celsius on some internal parts, maybe the switching elements or the heatsink attached to the switching elements. This is nothing too crazy, perfectly fine for those to be running at 50 to 60 degrees Celsius, given that the inverter is the most inefficient part of this system, and that's why we have that cooling fan in there to keep these things under control. So just to go over the results again, I was able to get 65 watts output on the USB Type-C. I was able to get 2.1 amps at 5 volts on each one of these 3 ports instead of the 3 amps claimed. I was able to get about 120 watts input into charging the station, so a little mismatch from what is claimed in the user manual. I did get the full 300 watts rated for the AC sockets, so a little mismatch on the USB ports from what is claimed in the user manual, but still perfectly usable. And for those of you wondering, this is how the pure sine wave looks like on the output of the inverter with about 120 watts of load. It looks like a pretty nice and clean sine wave. And by the way, this is being captured with my Mixig DP10013 high voltage differential probe input. So I think by now everyone watching, myself included, is keen to taking a look inside this unit to see what type of construction, what type of build quality, what battery technology they use in here, although I'm pretty sure it's some lithium-ion cells. So let's proceed with the teardown. There were 4 of these heavy-duty screws tapped from the bottom up, holding this thing together, but now it comes apart very nicely. We have these connectors that we need to remove before proceeding, and I'm noticing there are 2 cooling fans in here. Actually, there is a small one, and there is also a blower which connects directly to this vent, so it's presumably blowing out hot air from the inside of the case. So let me remove these wires so that we can proceed with the teardown. One thing that I always like to see on portable gear like this one is Celastic holding down the connectors, because you can imagine, this thing being subject to some drops or vibration which might make such a connector come loose. So it was fairly easy to take this apart. It's built on multiple decks or levels. It's very modular with connectors that you can remove after detaching the Celastic, so with nice attention to detail. The top part of the case holds just the wireless charger and the cooling fan, as well as the AC sockets. So nothing too interesting happening here, but notice the reinforcement ribs and the thick standoffs or mounting posts on this. It's definitely very sturdy. Then there is the inverter board, which has its own additional cooling fan, and the interesting part is that this board also has its own AllPower part number. You see it says here AP in, so I suppose that stands for AllPower Inverter 300 watt version. This makes me think it's designed in-house, and makes me think that AllPower is indeed an OEM for these power stations. Then there is the main board, also with an AllPower part number mentioned in here. So once again, a nice sight. The date code is from 2022, so it's a fairly recent design. There's lots of DC to DC converters in here, judging by the different inductors. The cigarette lighter socket looks really nice and beefy, like it could take a lot of current. And this board is generally getting powered through these big pads that just feed through some standoffs with screws from the battery board, which is behind there. On the battery pack, it looks like we have a number of 28 total cells. No apparent branding on the cells, except that they have a generic part number, the INR 18650-26E. But as expected, on this price range, we get lithium-ion cells, while lithium-ion phosphate is expected to be found on the higher capacity, more expensive units. There is even a thermistor buried deep inside the cell, so this board generally takes care of the battery management and just feeds power to the main board. There is even space for an additional 4 cells in here that they didn't need to populate on this particular unit. Overall, I'm positively impressed by the build quality of the unit. It's a really nice modular design. I see good components being used in here. Good assembly quality, and you can tell that whoever designed this has had some previous experience, because it's all nice and tidy with not a lot of wiring flying all over. The high power feeding lines are very short and optimized via those studs and going directly to these pads, and mechanically it's just held together with, again, some long screws, so no chance of anything rattling inside of here. So I'm just going to be putting this back together for further testing. It's May, it's warm outside, we got some beautiful sun on the Black Sea coast, so I brought my solar panel and the power station out for a test. And I like how this particular solar panel folds in just 2 big sections, makes it easier to fold and unfold. It also has these storage pockets for the accessories like cables and connectors. And after connecting the solar panel to the power station, I am getting peaks pretty close to the maximum power of the solar panel, even though it's just around 9 AM and at the time of this test. So I'm seeing about 80 to 83 watts out of the claimed 100 watts. But keep in mind, it's May, it's not full summer, the sun wasn't really up to full power yet. So I should be able to charge the power station fully in about 4 hours under these conditions. Could be faster, could be slower depending on the sun. But in a more mixed scenario with some clouds, not perfect sun, you'll maybe leave this solar panel connector for double that time to get a full charge. Also, a few things to note here is that the efficiency of the solar panel drops when it gets hot or when you have even small things casting shadows like some plants. So make sure you get full coverage on your solar panel for maximum efficiency, and a light breeze should take care of cooling the panel for maximizing the efficiency. And now it's time for my final thoughts on this combo of power station plus solar panel. And first, a few words about the solar panel. I think it is the correct size for this power station, giving reasonable charging times in good sun. It's a very nice build quality, does the job it was created for, so it's definitely worth getting it if you plan to recharge on the go from the sun. Now about the power station, at least for me, it is the perfect size, both in terms of battery capacity, but also physically and weight wise. It is a much better fit for me than the bigger blitzwolf station that I reviewed, that I've used previously. It's got lithium ion cells, so it's not the top of the line technology when you compare to lithium ion phosphate in terms of safety and number of cycles, but in this price range, lithium ion cells is what you get, which again, they're perfectly fit for the purpose. However, one thing to watch for is the temperature range, which they do mention in the user manual. It's 0 to 40 degrees Celsius. Don't try to charge this in below zero temperatures, as that will damage the batteries. I think it even has a protection feature that will prevent you from doing that. I just haven't checked it. In terms of DC outputs and features, definitely has less ports and less capability than the bigger power stations, but unless you have some very specific needs, it's no use for you just ticking them on a paper spec sheet. For example, it's no use to me if the blitzwolf station really outputs 3 amps on the USB type A ports, or in this one, or if this one just does 2.4 amps, because my phone is going to accept a maximum of around 2 amps anyway. But I do agree that they should update their user manual to include the real specification for these USB ports, maybe even mention them right here on the panel, because it creates confusion and disappointment if the user expects 3 amps and it's not getting it. The USB Type-C port has just 65 watts output, even though it claims 100 watts in the user manual, but maybe that's just some miscommunication when they wrote the user manual, I don't know. Bottom line is that 65 watts on a USB Type-C should be enough for most people. Most laptops just charge fine at 65 watts. The wireless charger is pretty useless, at least for me and the phone that I have. There's no way for me to align it on the wireless charging pad, not even when I rotate it 90 degrees, just doesn't catch the charging coil. A big advantage of this power station is that it comes with this status screen and the Bluetooth connection, which makes it very easy to monitor if your outputs are on or off, how much power goes in or out, especially when charging with the solar panel or when using the mains inverter. It also gives you control over the flashlight feature, which is pretty nice to have in a camping type situation. So because of the form factor, size and feature set, this will be my next preferred power station to take with me when going on a trip. Might be a different set of requirements for you, but definitely worth checking this one out if you're in the market for such a gadget. The build quality that we've seen during the teardown definitely speaks for itself. There will be a link in the description of the video with a discount code for you to use should you choose to order this one. And that was all for today. I hope you enjoyed this review and teardown. As always, I am interested in hearing your thoughts in the comments below. Thank you for watching, and if you enjoy these videos, you can help support the channel with as little as $1 per month via Patreon, or you can just hit that like button, which is free but still helps a lot.